Okay, 8.3 or 9.3, depending on which syllabus you look at, is kind of continuing the theme that we saw in 8.1 and 8.2 of we're still dealing with essentially quadratic equations that have x squared, but we're putting a little bit of a spin on it. And the spin in the first two sections was equations don't really seem factorable, but they're still solvable. And here we're going to have similar flavor to that. We're going to have equations with like x to the fourth that seems like it's not a quadratic and seems like we couldn't really factor it, but we actually can using this idea of substitution. And so this is a perfect example of just that. I have p to the fourth minus 7p squared minus 144 equals 0. So it seems like I can't factor this, at least not with what we've learned so far in the class. We usually have like a p squared minus 7p minus 144, and then we have a ton of strategies to solve those equations. And so since we have a lot of strategies to solve those equations, we're going to change this equation to make it look like that. And we do that through substitution. So we say, okay, I'm going to let u be equal to p squared. That's typically going to be kind of that center term. Because if I say u is equal to p squared, well, I can substitute in u for my p squared in that term. And also my first term, instead of being p to the fourth, will now be u squared, right? Because p squared squared is p to the fourth. And so now with this substitution, I have an equation I can factor. In fact, I could use quadratic formula, or I could use completing the square if I want to, but in this case, factoring is not too terrible. So I'm going to factor this equation for you. So two things that multiply to get me negative 144 and add to get me negative 7. Well, those two things are negative 16 and 9. But the question's not asking for what are my values of u. So kind of take a step back. This is my factor form. I have u minus 16 times u plus 9 is equal to 0. And if this was a regular factoring question, I would set each equal to 0 and solve. But I'm not solving for u. I need to somehow go back to my original equation where I have a p. And so I do that by swapping my u out for my p again. So instead of u's, I'm going to put p squared. I guess x squared, it should be p squared. I'm going to put x squared back into my equation. And then I can go back to the classic. I'm going to set each part equal to 0 and solve. So x squared minus 16 is equal to 0. X squared plus 9 is equal to 0. Add 16 to both sides, square root. And anytime we take a square root of both sides, we need to do plus or minus. Square root of 16 is 4, so I get x is equal to plus or minus 4, or p. Again, every line after u should have a p instead of an x. I think I kind of just defaulted to x because that's kind of the classic solver, but this should be p. And same thing with the next part. X squared plus 9, I subtract 9 from both sides. I square root both sides. Square root of 9 is 3. I'd have a negative square root, so I would get plus or minus 3i. So that's a good example of questions that previously weren't solvable are now solvable because we're able to kind of manipulate them and get it into this form that we have some comfort with. So this next example, I wouldn't say is absolutely necessary to use substitution, or kind of the fancy word term for it in calculus is called U substitution, but it certainly helps. So the two options we could have here is that we could FOIL out our x plus 2 squared and then distribute out our x plus 2 in the second term and then simplify all the way through and then factor and then solve. But we notice here again, my first term is an x plus 2 squared. My second term is an x plus 2. So this is a good case where I could use this trick of u substitution or substitution. So I'm going to say u is equal to, in this case, x plus 2. Now I substitute out my x plus 2 with a u, so I get u squared minus 2u minus 3 is equal to 0. And then again, I can factor this. I know how to factor this. Two things that multiply to get me negative 3 add to get me negative 2 are negative 3 and 1. And then just like we saw in the last example, we're not asking for what u is. We're asking for what x is. So I need to substitute my u equal to x plus 2. I need to put that x plus 2 back into my equation. So I replace both of my u's with x plus 2. And then I do a little bit of simplification. 2 minus 3 gets me -1. So my first factor is now going to be x minus 1 as opposed to x plus 2 minus 3. And my second factor is going to be x plus 3 as opposed to x plus 2 plus 1. And now I can set each part equal to 0 and solve. So x minus 1 equal to 0, I would add 1 to both sides and get x is equal to 1. X plus 3 is equal to 0. I would subtract 3 from both sides and I get x is equal to -3.